Bismillahirrahmanirrahim. Assalamu alaikum, dear students. How are you? I hope you'll be fine. This is Cambridge Lower Secondary Book 8. And today we are starting with chapter number 1, which is related to factors and multiples. So let's start with question number 1, which says the factor tree for 120 started with 12 into 10. So you can see in your book on page number, it's given on page number 11, I guess. Yes, it's given over there that the factor tree of 120 starts from 120. They splitted it into two parts. That is, two of its factors, that is 6 multiplied by 20 is equals to 120. And then they further split it into, they further split it 10 into 2 into 5. And then 20 into 3 into 4. And then 4 into 2 into 2. Acha, what does factor tree helps to find in? It basically helps us to figure out that what are the prime factors of a given number, of the original number. So we have to draw a factor tree for 120 that starts with 6 into 20. The factor tree that was given on the previous page, on page number 11, started with 10 into 20. But we have to start it from 6 into 20. It was 12. Okay. You can start with any of the pair factors of 120, right? But since it specifically tells us that we have to start from 6 into 20, so we will are starting it from 6 into 20. So it will give us, it will further split into 2 3s are 6, and 20 will split into 2 into 10. Then 10 will further split into 2 into 5. So the final prime factors we got are 2 into 3 into 2 into 2 into 5. Okay. And in the first one, we had 2 into 5 into 2 into 3 into 2. So you will find that in both the cases, we are getting the final prime factors that are the same. 2 into 5 into 2 into 2 into 3. So we have a total of 3 2s, 1 5 and 1 3, be it any pair factor we are taking. So what pair factors do we have for 120? So if we split 120 into pair factors, it's 1 into 120. You can start from here, okay? But we are not going to start it from 1. So we can start from 2, 2 into 60. Okay, here we have already one of the factors as prime factors. So we'll split 60 into further parts. Then you can split 3 into 40. 3 is a prime factor. So only you are going to split 40 into a further pair factors. And then 4 into 30. And then 5 into 5 twos are 10, and then 5 24. Then 6 into 20, as we have already done it. Then 7 is not a factor of 128. 8 is a factor of 120 or not. Let's check it. Yes, 8 into 15. So we can split it into 8 into 15 as well. And then the next few factors are 10 into 9 is a factor of 120. No, 9 is not a factor of 120. Next one is 10 into 12, and that's all. We do not have any other factors because after 10, 12 is the factor and it's already covered over here. So now the factors are 15, 20, 24, 30, 40, 60, and 120. So that's all the pair factors. So what factors have we taken? We have taken 10 into 12, okay, which was given in the book. And then they asked us to take this pair factor, that is 6 into 20. So after drawing this pair factor, you have to compare your answers with that of your partners. And then you have to draw some other factor trees for 120. So they are saying, can you say how many different trees are possible? No, we cannot say. Because there are multiple ways of splitting 120 into its pair factors. Okay. But yes, for the answer to party, do all factor trees for 120 have the same endpoints? Yes, exactly. All of them have the endpoints as 2 into 2 into 2 into 3 into 5. Let me show you over here. Let's take one more pair factor of 120. Let's take 4 into 30. Okay. So 4 can be splitted into 2 into 2. So these are the prime factors. And for 30, it can be further splitted into 2 into 15. And then 15 can be further splitted into 3 into 5. So you will find that 2, 3, and 5 are the endpoints along with other two. So again, we have 1, 2, 3. 3 twos, 1 3 and 1 5. So you see, let's take one more. If we, let's say, split 120 into 5 into 24. So 5 is already a prime number. We are not going to split it in anymore. But 6 into 4 and then 2 into 3 and then 2 into 2. So again, the pair factors, the endpoints are the same. That is 5 into 2 into 3 into 2 into 2. You see? So whatever pair factor you are going to take, you will get the same endpoints. So this is one of the methods of expressing a number as a product of its prime factors. So I can write it like this. You see, 120 is basically equals to 2 into 2 into 2 into 3 into 5. Whatever uh, pair factor you are going to split 120 in, the ultimate answer would be this one. And this is called expressing 120 as a product of its prime factors. So 120 becomes product of its prime factors. Okay. We use one more method that is called prime factorization. Okay, that's also quite similar to this method, but that's quite different. Now the next question is complete this factor tree for 108. They have already split it into one of its pair factors, that is 2 into 54. If you multiply 2 with 54, you will get 108. So now we are going to split it into 54 into 2 into 27. Okay, or you can split it into 9 into 6 as well. Okay, that's also correct. And then we can split it into 3 nines are and then 3 threes are. So the endpoints are 2, 2, 3, 3, and 3. These are the endpoints. So we can express 108 as a product of its prime factors, like 2 twos are 4, 4 threes are 12, 12 threes are 36, 36 threes are 108. Okay. Now we have to draw another factor tree for 108. So we can split it into one of its pair factors. Like 108 is a multiple of 12, I remember. 12 into 9 is 108. Yes. So let's split it into two parts. That is 3 fours are and then 3 threes are. So since these threes are prime numbers, we cannot split it anymore. These are the endpoints. And then for 4, we can split it into 2 into 2. So again, the pair factor is 3 into 2 into 2 into 3 into 3. Again, we have a total of 2 twos and 3 threes, which is the same as the first one. Then they're saying, write 108 as a product of its prime factors. We have already done it over here. This is how we can express 108 as a product of its prime factors. That's all. Here comes the next question, which says, draw a factor tree for 200 that starts with 10 into 20. So let's start it over here. 10 into 20 is equals to 200. So we will split 10 into 2 into 5. 2 fives are 10. Both are prime numbers. So they are the endpoints now. And for 20, we can split it into 4 into 5. So 5 is again an endpoint. So 4 can be split into 2 into 2. So it's done. Okay. Now we have to write down 200 as a product of its prime numbers. So it would be 2 into 5 into 2 into 2 into 5. 2 fives are 10, 2 fives are 10, 10 tens are 100, 100 twos are 200. You see? Now, how many different factor trees can you draw for 200 that start with 10 into 20? Let's see. If we start it with 10 into 20, so 10 can be split into 2 into 5. There ain't any other pair factor of 10. Okay. And for 20, we can split it into 2 into 10 as well. And then it would become 2 into 5. So this could be another method we can use over here. And is there any other method we can use? Because the factors of 20, pair factors of 20 are 2 into 10 and 4 into 5. So there's one more method that we can split it as it is. Okay. Here comes the next question, which says draw a factor tree for 330. So let's start 330 with 33 times 10. Okay. Let's take an easy pair factor. And then 33 can be split into 3 into 11. Both are a prime numbers. And then 2 5s are. So all of them are prime numbers. So we have to express 330 as a product of its prime factors. It would be, let's start from the smallest, 2 into 3 into 5 into 11. That's all. Okay. We will take only the endpoints for writing 330 as the product of its prime factors. We are not going to take 33 and 10. We are not going to take those factors that can be further splitted in two parts. Okay. Now they are saying match each number to product of prime factors. So if we talk about 20, it's 2 square into 5. Now let me tell you another method of finding the prime factors of a number. Let's take 24. Start dividing it with the smallest prime factor, that is 2. 2 12s are 24. Still, it's an even number. So we will keep on dividing it with 2 until and unless it's an even number. 2 6 are 12. Again, 2 3s are 6 and 3 1s are 3. So the factors of 24 are 2 raised to power 3 because we have 3 2s into 3. 2 raised to power 3 means 2 multiplied by 2 multiplied by 2. So I can write it in the index notation. So the correct option would be fifth one. You see? Now let's do it for 42. It's an even number. Let's start dividing it with 2, 2 into 21. But now it's an odd number, but it's divisible by 3. So 3 sevens are 21 and 7 ones are 7. So we have got 2 into 3 into 7. So this is called prime factorization. Okay. So 42 is equals to 2 into 3 into 7. That is the correct option is number 2. And then we have 50. So 2 into 25, 5 into 5, 5 ones are. So it's 2 into 5 into 5, which is 2 into 5 power 2, because we have two fives. So it becomes, the correct option would be number 4. And of course, we are left with the last option. So it must be 180 is equals to 2 square into 3 square into 5 square. Let's try to prove it that yes, we are getting the same thing over here. 2 into 90, 2 into 45, then it's divisible by 3, 3 into 15, then 3 5s are and 5 1s are. So we can express 180 as a product of its prime factors. That is 2 into 2 into 3 into 3 into 5. So we have a square of 2, a square of 3, and a 5. It becomes 2 square into 3 square into 5, and hence prove that yes, this is the correct option. Now, in the next question, we have to do the reverse of what we were doing up till now. We are provided with the prime factors and we have to figure out the product of it. That is the real number. So it's 3 square into 5 into 7. 3 square means 3 into 3 into 5 into 7. So 3 3s are 9. 9 5s are 45. 45 into 7 is equal to 315. So it's 315, which means that 315 has the prime factors of 3 square into 5 into 7. Then the next one is 2 cube into 5 cube, which is 2 2s are 4, 2s are 8 into 5 5s are 25, 5s are 125. So we can multiply 8 with 125 and the answer would be 1000. Okay. It means the prime factors of 1000 equals 2 cube into 5 cube. The next one is 2 square into 3 square into 11, which is 2 times 2 is 4. 4 3s are 12. 12 3s are 36. 36 11s are 396. So the answer to this one is 396. Next we have 2 power 4 into 7 square, which is 2 2s are 4, 2s are 8, 2s are 16. 16 into 49. Okay. So let's multiply 16 with 49 and the answer is 784. And for the last one, we have 3 multiplied by 17 square. 17 square means 17 multiplied by 7. Okay. 17 multiplied by 17 is 289. And 289 multiplied by 3 is equals to 867. So 867. That's all. Okay. So what do we have to do in the next part? We have to write each of these numbers as a product of its prime factors. So we will apply the prime factorization method. You can go for, let's do some of them with the factor tree method and some of them with prime factorization. So let's start 28. 2 into 14, 2 into 7, 7 into 1. So it would be 2 square into 7, right? Then for 60, 2 into 30, 2 into 15, 3 into 5, and 5 into 1. So it would be 2 square because we have two twos into 3 into 5. Next we have 72. 2 into 36, 2 into 18, 2 nines are, and 3 threes are, and 3 ones are. So it would be 2 to the power 3 and 3 to the power 2 because we have 3 twos and 2 threes. So it becomes 8 nines are 72. Let's do the remaining ones using the factor tree method. Okay. So let's talk about 153. 153 is an odd number, but it's divisible by 3. So let's split it into two parts, that is 3 into 51. Then again, 51 is divisible by 3. So it's 3 into 17. Right? So it would be 3 square because we have two threes into 17. Right? Then let's do it for 190. So let's split it into 19 into 10. 19 is a prime number. So let's keep it as it is. Split 10 into 2 into 5. So it would be 2 into 5 into 19. For 275, it would be, we can split it into two parts. Let's divide 275 by 25. So 25 11s are 275. 11 is a prime number, just leave it. And for 25, it's 5 into 5. So it's 5 square into 11. That's all. Next, we have question number 8, which says copy the table and write each number as a product of its prime numbers. It's the same. Okay, but this time what you will find that all of the numbers are multiples of 35. So if you see 70, 35 times 2 is 70. Okay, then 70 times 2 is 140. And then 140 times 2 is 280. So instead of finding their prime factors every time, we can simply multiply 2 every time into the given factors of 35. 5 sevens are 35. 35 twos are 70. 5 sevens are 35. Twos are 70. And 72s are 140. Okay. Then 5 sevens are 35, 35 twos are 70, 72s are 140, 142s are 280. So every time what are we doing? We are simply multiplying the previous number with one more 2. And we have got the prime factors of 280. Now we have to add more rows to the table to continue the pattern. So in this case, what are we going to do? We will simply multiply 280 with 2 and then answer would be 560. So the next number would be 560 and the next number would be 1120. You can go on every time you are going to add a 2 only. So you can write it as 2 power 4. This one would be 5 into 7 into 2 power 5 and so on. Okay. So you can write it over here as 2, then 2 to the power 4, 2 to the power 2, 2 to the power 3 and so on. That's all. In the next question, question number 9, we have to write 1001 as a product of its prime factor. So let's find out the very first pair factor of 101. It's 11 into 91. 11 times 91 is equals to 1001, right? And then we can split 91 into further parts. 91 is a prime number or a composite number. So yes, 91 is a composite number. It can be further split it into 7 into 13. So we can say that 13 multiplied by 7 multiplied by 11 equals to 1001. So we can write 1001 is equals to 7 times 11 times 13. Now in part B, we have to write down 4004 as a product of its prime factors. And we know that 1001 multiplied by 4 is equals to 4004. So instead of finding out its prime factors, we simply find the factors of 4, that is 2 into 2. So we can write down 4004 as 2 to the power 2 into 7 into 11 into 13. Instead of finding out its prime factors one more time. But still, if you want, you can find out its prime factors. So you can write it as 4004 can be split it into 4 into 1001 initially, the first pair factor. And then you will find that the same factors you are going to get as you have already got in the previous question. So what it means? It means that the previous factors would remain the same. We are going to add the factors of 4 only, which is 2 into 2. See? And without even finding the prime factors using this factor tree, we can now figure out that what would be the prime factors of 6006. So it would be, since we know that 6 times 1001 is equals to 6006. So we can split 6 into 2 parts, that is 2 times 3. 2 into 3 into 7 into 11 into 13 would be the factors of 6006. Okay. When we had 4, we split it into 2 into 2. Now we have 6, so we split it into 2 into 3. So this would be the answer to part C. Next, in question number 10, they are saying, use a factor tree to write 132 as a product of its prime factors. Fine, we know that 132 is a product of 12 into 11, and 12 can be split into 3 into 4, and 4 can be split into 2 into 2. So we can say that 132 is equals to 2 square, right, into a 3 into 11. Okay, this is how we can express 132 as a product of its prime factors. The prime factors of 132 are 2 square into 3 into 11. Next, they are saying write 150 as a product of its prime factors. So let's write it down over here. 150. For 150, it would be 15 into 10. Okay. And then 3 into 5 and 2 into 5. 3, 5, 2, 5 are the prime factors of 150. So we can write it as 2 times 3 times 5 squared because we have 2 5s. Next, they are saying 132 multiplied by 150 is equals to 19800. Use this fact to write 19800 as a product of its prime numbers. Okay, instead of finding out the prime factors of 1980 using any of the two methods, that is prime factorization or factor tree method, we can use the fact 132 multiplied by 50. Since 132 multiplied by 150 is equals to 19,800. So we can say that the factors of 132 are 2 square into 3 into 11, and that of 150 are 2 into 3 into 5 square. So the factors of 19800 would be together the factors of 132 and 150. So we will have 2 square into 2, which is 2 to the power 3, because when we multiply the same numbers, their powers will be added. So it becomes 2 square means we have 2 2's, and multiply by 2 means we have 3 2's. So it becomes 2 to the power 3. Then we have 3 multiplied by 3. So it becomes 3 square. Then we have 5 square. And then we have 11. You can verify your answer by finding out the factors of 19800 separately as well. But you are going to get the same answer. That is, the prime factors of 19,800 would be 2 into 2 into 2 into 3 into 3 into 5 into 5 into 11. That's all. Now, in the next question, first we are going to find out the factors of 15. So it would be 3 into 5. And when we have to find out the factors of 15, so every factor would be squared. It becomes 3 square into 5 square. That's all. If 15 is equals to 3 multiplied by 5, we have 1315. So in the square of 15, we will have 2 3's and 2 5's. For 28, 4 times 7 and 2 times 2. So since the factors of 28 is equals to 2 to the power 2 into 7, so the factors of 28 square would be 2 to the power 4 into 7 into 7 raised to power 2. That whatever power we have, it will double when we will square the number. Okay? So if the power is 1, the power will become 2. If the power is 2, the power will become 4. If the power is 3, the power will become 6, and so on. Then for 36, it would be the same. Since we know that 36 is equals to 12 multiplied by 3. Or let's take 6 multiplied by 6. And then 2 3's are 2 3's are. So the factors of 33 are 2 square into 3 square. So when we will find the square of 36, the powers will further squared, and it would become 2 to the power 4 into 3 to the power 4. And you can check it. Okay? When you will square 36, what are you going to get? It will be 1296. And when you will find out the factors of 1296, it would be having 4 2's and 4 3's. So instead of finding out the factors separately, we can simply double the powers to get the prime factors of the square number. So what do you notice about your answers to part 1 and 2, 3 and 4, 5 and 6? We notice that every time we square the number, their factors are also squared. Or you can say that their factors, the powers of the factors also get doubled. That's all. So if 96 is equal to 2 power 5 into 3, show how to find the prime factors of 96 square. It's very simple. If the factors of 96 is 2 power 5 into 3, the factors of 96 square would be 2 to the power of 10, double of 5 is 10, and that 3 to the power 2, because double of 1 is 2. Every number that does not have any power shown, it means it has power 1. So when we are going to double it, it becomes to the power 2. That's all. So we have completed till question number 11, inshallah. In the next video, we are going to do few more questions of this exercise. Until then, take care. If you are new to my channel, don't forget to subscribe and share it with your friends so more people can benefit from it. Take care. Allah Hafiz.